Alright, this will be another examples of parametric differentiation. So we have x and y in terms of t. So this is a parametric equation. So, alright, let's see how to solve this type of problem by finding the dy dx, right? They require to find dy dx. So to find dy dx, you know that dy dx in parametric differentiation, we are using chain rule, which is dy dx, and we differentiate the y with respect to t, the dx with respect to t. So we need this. So as t is your parameter in this case. So okay. So for now, I'm going to find my dx dt. I know this is 4t to the power of -1 minus 9. And this will be, okay, this one I will apply the UV, okay, your quotient rule. As I see quotient here. So for this one, I just apply basic rule as t power of -1. So dx dt, you will have -4 t to the power of -1, right? So you have -2. Differentiate -9, you have 0. So you have -4 over t to the power of 2. Dx dt will be -4 over t power of 2. So usually you were using the dt dx, right? dt dx. So dt dx is the same as -t squared over 4, right? T squared over 4. So differentiate. Alright, let's move on with y as this one. I want to apply the quotient rule. Okay, quotient rule, which will be vu prime minus uv prime over with v to the power of 2, right? So dy dx, dy dt, right? So v will be your t square minus 2, t square minus 2. Differentiate u prime, right? Differentiate differentiate this. Differentiate t square, 2t. Differentiate 2, 0, right? Negative with t square plus 2, u, right? u, v prime. So you have 2t. Differentiate t square minus 2, 2t, over with t square minus 2 to the power of 2, v square. So you simplify, and you will have 2t cubed, right? 2t cubed minus with 4t, 2t cubed minus with 4t, negative with 2t cubed, 2t and t squared, 2t cubed, and the negative here, negative 2t cubed, and negative 2 4t. So I further simplify, I can see that these two will be cancelled off, right? One positive, one negative. So I have remaining of negative 2 4 8. So t squared minus 2 to the power of 2, right? So this will be your dy dt. So I have my dy dt. So it's time for me to find my dy dx. Alright, now we're finding for dy dx, right? Dy dx is dy dt negative 8t over t power of 2 minus 2 to the power of 2 multiply with dt dx. Dt dx, right? Dt dx. So you will have negative t to the power of 2 over 4, right? Negative t to the power of 2 over 4. So, okay, for now then I have 4 2 8, right? Negative positive 2t to the power of 3. So t to the power of 2 minus 2 to the power of 2. So this will be your dy dx for this parametric equation here. So let's move on to finding the second order differentiation of second derivative of dy of y. Alright, let's continue by finding the second derivative. As you know that the second derivative, the formula will be d2y dx2 equals to d dt of the dy dx multiply with dt over dx, right? So this is the second derivative formula. So then I want to find d2y dx2. So I have to differentiate d dt to the dy dx. Now the dy dx in this case will be 2t cubed over with t square minus of 2 to the power of 2 multiply with dt dx, dx dt, right? Dx dt is negative 4 over t square. So dt dx will be negative t square over 4, right? Now you just focus on this part here, which you need to differentiate, right? You differentiate, this one is your u and this one is your v, right? U over v. So we need to differentiate this by using quotient rule, right? So as quotient rule is written as u v u prime minus u v prime over with v to the power of 2. So you see here you have u v. So follow that order. So you differentiate. So u v minus 2 to the power of 2 v, differentiate u prime. So you will have 3 to 6t to the power of 2 minus with 2t cubed u ikut tertib ini u differentiate v. So differentiate v. Differentiate v. Be careful when you differentiate v because this is a power, right? You have a power. So to differentiate this, you have to bring down the power 2. So 2t square minus 2, right? 2t square minus 2, salin balik, copy back. Then the 2 minus 1, right? Then the 2 you minus 1. Then later differentiate, right? Differentiate inside the function inside the bracket. So t square minus 2, which will be 2t, right? Differentiate the function inside here, you are getting 2t. So everything, overall everything, you divide by v to the power of 2. So this is v. V is t square minus 2 to the power of 2. Now you v square, square again. So you are getting power of 4, right? So don't forget to multiply. Don't forget to multiply with negative t square over 4. Right? So if you rearrange, you can actually, okay, because this question they require you to evaluate. They want you to evaluate d2y dx2. So I try to lessen the time, the time for me to arrange this. I just write it nicely so that later I know this is 6t square, right? 6t square multiply with 6t square multiply with t square minus 2 to the power of 2, right? Minus 2 to the power of 2. So minus with, okay, everything inside the bracket. So 2 times 2, 2 times 2, you have 4, right? 2 times 2, you have 4. T cubed multiply t, you have t to the power of 4, right? T cubed must multiply t, you have t to the power of 4. And followed by, then you have 2 here, right? 2, 2, 2, you have 8. Suppose here you should have 8. You have 8. So 2, 2, 2, 8. And t cubed and t power 4. And you have remaining one more is t square minus 2. 2 minus 1, power 1. Everything divided by t square minus 2 to the power 4. Okay, all inside here. Then I multiply with negative t square over 4. Okay, it seems like very hard to simplify this thing, right? Very hard to simplify this thing. But try to look at the question, okay? The question in the lecture notes, okay, is saying that determine the value of d2y dx2 when x is negative 5. Alright, the question requires you to find d2y dx2 when x is negative 5, right? You want to find the value. You need to find the value of d2y dx2. So, but you know that your d2y dx2 is in term of t, right? In term of t. But the given here is x, right? X is negative 5 here. So with this information, you can find the value of t by substituting this x equals to negative 5 into the parametric equation. As you see here, you can relate x with t, right? So when x is negative 5, so you know that negative 5, substitute the negative 5 inside here, you will get the value of t, so which is 4 over t minus 9, right? So 4 over t minus 9 is negative 5. So negative 5 plus 9, you have 4 over t equals to 4, right? So t will be t switching, so 4 over 4. So you are getting 1. With the value of x negative 5, you can get the value of t, right? So when x is negative 5, t is 1. So you're using the value of t equals to 1, substitute into the d2y dx2, and you are getting your value of d2y dx2. So now d2y dx2, when t is 1, so you can substitute inside here, you are getting, so you try to evaluate 1, right? T is just 1. So 6 times 1, 6 times 1 square, you have 6, right? So 1 square minus 2, right? 1 square minus 2. So you remember t is 1 now, 1 square minus 2. So you have negative 1 to the power of 2, right? 1 minus 2 is negative 1 power of 2. Minus with 8. Minus with 8, as t is 1, 1 power of 4. 1 power of 4 is 1, right? And you have t square minus 2, right? T square minus 2 is 1 minus 2, right? 1 square minus 2. So you have negative 1. So without arrange this thing, we directly substitute the value of t because we want to evaluate, right? So, and this one you have t square, which is 1, right? 1. So 1 square minus 2, negative 1 to the power of 4. So multiply with negative 1 over 4. T square, 1 square, negative 1 over 4. So now you can evaluate this number here. So 6 times negative 1 square, you have 6. Negative, 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 you have positive, right? Negative, negative, you have positive 8. Same, very easy, right? Negative, negative, positive 8. So negative 1 to the power 4. Negative 1 to the power 4, you are getting positive 1. Multiply with negative 1 over 4, right? So negative 1 over 4. So then you are getting 8 plus 6, 14. Negative, multiply negative 1 over 4, you have negative 14 over 4, which is negative 7 over 2. So means that d2y dx2 is equals to negative 7 over 2 when x is negative 5, right? So I hope you understand. Alright, that's all for this video.